Welcome to the WeEn Semiconductors contribution to Bodo's Wide Bandgap event 2022. First, you can see a short history of our company. WeEn Semiconductors is a spin-off from NXP Semiconductors, and for a number of years we are already doing silicon carbide diodes and MOSFETs. Now we are entering the automotive market with silicon carbide diodes and MOSFETs. The vision of our company is to become the leading China-based power semiconductor supplier. WeEn already has a large portfolio of silicon carbide diodes and silicon carbide MOSFETs. And now WeEn is proud to announce that next year we will introduce a range of automotive qualified silicon carbide diodes, followed later by automotive qualified silicon carbide MOSFETs. These are the silicon carbide packages that we are doing currently and in the future. For discrete packages, at the top you see diode packages like the 2-pin TU247 or D-pack, D2-pack, and at the bottom we see 4-pin TU247 and, for instance, the 7-pin D2-pack. Our silicon carbide technology is evolving all the time. For silicon carbide diodes, we are working on lower VF by using innovative and optimized MPS structures and wafer thinning, lower thermal resistance by using silver sintering, innovative packages and also wafer thinning. For silicon carbide MOSFETs, we have reached lower specific on resistance by using a very good cell structure, and in the future we will move from planar to trench. We have reached high robustness, lower thermal dependence and low parasitic inductance because we can offer packages with a Kelvin pin connection. In the picture, top left, we see electrical field, thermal conductivity, melting point, electron saturation velocity and bandgap. And we see that silicon carbide outperforms silicon by far on all these specification points. In automotive applications like onboard chargers, DC-DC converters, you can have many benefits. There's a reduced cost and size of passive components because of the higher switching frequency. You can have a reduced heatsink, there's higher efficiency, there's weight reduction, you can have a longer range for the car and a faster charging of the car. Here on the left we see the much improved switching behavior of silicon carbide compared to silicon. The worst case line is the purple one, a silicon diode switching off at 125 degrees Celsius, and we see a lot of unwanted negative current overshoot and nasty oscillations. Silicon carbide has much better and temperature independent switching behavior. In the picture on the right we can see that you can always parallel silicon carbide diodes because of the positive VF versus temperature coefficient. In the table, we see that our MPS diodes are actually the best of both worlds if you compare them with normal Schottky barrier diodes and PN diodes. They are good for VF, IR, reverse current, IFSM inrush current, and fast switching. At the top of this slide, we see the side view of a silicon carbide diode die. In the top of the die, we see the P and P+ implants that actually will lead to lower leakage current and a higher inrush current. At the bottom, you see that we have taken away part of the substrate. This will lead to much better VF and lower thermal resistance. In 2023, WeEn will introduce 650 volt and 1200 volt automotive qualified silicon carbide diodes. WeEn already has a comprehensive portfolio of 650 volt silicon carbide diodes. Blue and green dots indicate standard and low VF. A number of AEC-Q 101 qualified parts will be introduced at the beginning of next year. And this is the overview of the 1200 volt silicon carbide diodes. Red dot indicates automotive qualification to be introduced next year. Now let's have a look at silicon carbide MOSFETs. Last year, WeEn introduced its first silicon carbide MOSFETs. They feature low on resistance, fast switching speed, 0 volt turn-off gate voltage. They're easy to parallel, Applications can be onboard chargers, DC-DC converters and motor drives. On this slide we see the development of the silicon carbide MOSFET chip technology. On the left, the Generation 1 silicon carbide MOSFET made in planar technology. In the middle, our soon-to-be introduced Generation 2 silicon carbide MOSFET. And on the right-hand side, our next generation silicon carbide MOSFET made in trench technology. Here we see that newer generations for silicon carbide MOSFETs have lower specific resistances. Innovation drivers are figure of merit, specific resistance, and automotive grade qualification. Here we see a graph of normalized RDS-on versus temperature for two silicon carbide MOSFETs. The RDS-on increase with temperature for the WeEn part is lower. Excessive ringing on the gate can damage the gate oxide. This is why we pay a lot of attention to gate oxide reliability. Apart from the standard TO247 package, for silicon carbide MOSFETs, WeEn also offers the 4-pin TO247 package. This package offers a Kelvin source. Using this package, the customer will have lower switching losses and lower ringing on the gate, which can be seen on the picture on the right. To verify long-term reliability, many tests are being conducted in the reliability lab. Some typical results of those tests are shown on this slide. WeEn will introduce silicon carbide MOSFETs in the packages TO247, TO247 4-lead and D2PAK 7-lead for both 750 volts and 1200 volts. In the future, we will also introduce automotive qualified MOSFET modules. Measurement on this DC-DC converter evaluation board clearly shows the increase in efficiency using silicon carbide devices. Because of the higher switching frequency, inductors will be much smaller, as can be seen in the picture bottom left. An onboard charger uses many automotive qualified silicon carbide diodes and MOSFETs. From left to right we see AC mains, a bridgeless rectifier stage, an LLC stage, galvanic isolation with a transformer, high frequency rectification with silicon carbide diodes, and on the right hand side the high voltage battery of the electrical vehicle. Some onboard chargers can be used as a DC-AC inverter to deliver power to the house. All silicon carbide diodes in the schematics have now been replaced by silicon carbide MOSFETs. The functioning is from right to left. On the right hand side we start with the charged battery in the car, then we see the LLC stage, galvanic isolation, high frequency rectifier stage, the inverter stage, and from there we deliver AC power to the house. The last application slide is about electrical vehicle motor drive. This is a DC to AC inverter. Many silicon carbide MOSFETs can be placed in parallel to achieve the desired power level. After having delivered millions of silicon carbide products to industrial markets, WeEn is now thrilled to enter the automotive arena. We have a global footprint to support global customers and a long experience with automotive standards. Furthermore, we have an ambitious plan to build up our own manufacturing capability. Thank you for watching this WeEn movie on automotive qualified silicon carbide diodes and MOSFETs. And please join the live Q&A session.